This conference will now be recorded.
Okay, so good morning all and welcome back to the session. This is Big Data Masters program and we are going through with PySpark. And from the PySpark perspective, RDs has been done and we are going through with data frames, and this is the second session onto the data frames. So in previous session, from the data frame perspective, what we have seen, like data frames are nothing but higher order APIs from the Spark side or higher order construct from the Spark side, which are having the benefit of schema. And with the help of like the Catalyst Optimizer and Tungsten Engine, we will be the Spark is going to optimize data frames, and these are more optimized, you can say, way of working with Spark. So if you are having certain data, then definitely like try to proceed with data frames. Okay, so that is nothing but data frame. And once we are working with data frames, or once we are designing an application in this particular world, then there are three main steps. Reading data, let me write it down, or let me walk you through with the stuff what we have seen. So flow of an application, how an application is designed and delivered. So what we are having three main phases. We are reading the data, we are processing on top of that particular data and getting the output. This is the normal flow. Okay, you can take a factory. In that particular factory, what we are having certain raw data or raw, you can say, material that is processed, and what we are getting a product in the output. So same thing is, you can say, applicable over here. PySpark is nothing but working as a factory, and in this particular factory, data is the input. We are performing processing with respect to the transformations and all, and what we are getting fine-tuned data. Or you can say we are having row counters over here. We are processing those particular row counters and we are getting the KPIs. If we are simulating it with the help of like telecom domain and other, you can say, domains. So raw data or input is nothing but reading the data. Okay, reading the data phase is there, and in previous session we have gone through with that particular stuff, how to read the data. Okay, so how to read the data, this was covered in previous session. How to read the data. Okay, so from the data reading perspective, we have gone through with standard data read API. Okay, standard data read API, what was that? Like, we just need to mention this particular stuff. Okay, this is standard data read API. Like over here, we are deciding what is the input format. Then do we need to have header? Is schema is inferred over there? Like, do are we moving with Spark functionalities in order to define the schema for our data? Then what is the mode? Like, we have gone through with modes as well: permissive, fail fast, and drop malformed. So over there, with respect to those particular modes, we are reading the data. Okay, like if certain mall records are there, corrupted records are there, then how these particular modes are behaving? Over here, we are mentioning the path of that particular file, like where this particular file is located, and then we are loading it. So this is nothing but reading data, standard data read API. We have gone through with schema, like schema definition and all, how to define the schema. Okay, so we have gone through with that particular phase as well. So this we have seen in our previous session. Like, there are three main methods. Infer schema, we are leveraging the Spark functionality in order to define the schema on top of our data set. Then the programmatically defining the schema and DDL string, those are the two other formats for schema definition. So it depends upon us which one we are going to use based upon our you can say understanding. So that is the first, you can say, part, how to read the data. Second one is the processing or applying transformation. So today we will be discussing about the second phase, and our major discussion will be on to the second phase only. Writing data, that is not taking much time. Okay, over here we will try to like get the feel of the data. Okay, then we will try to apply certain transformations and all in order to process the data. Like if you want to filter, so filter transformation is there, you need to perform the joining and all. Over here, we will be discussing about optimization techniques, bucketing, partitioning, okay, then caching. Okay, we will discuss those particular things. Finally, once these particular things are over, okay, like you read the data, then you have processed the data and you have written the code to take the output. Once the complete code is over, once the code is complete, in other words, okay, then you will be moving to submit this particular code onto the Spark cluster. How to submit this particular code on Spark cluster, so we will see. Okay, so over here, like we are writing the code and then executing it, so it is going on to the Spark cluster. So this is one way of executions, like through the IDE we are executing this particular code. Second mode is through the Spark shell. Okay, like we are onto the command prompt, we are typing PySpark. Okay, and command by command we are just typing the code and we are getting the output. This is second way of executing or running the code on Spark cluster. Third way that is preferred inside the market, that is submitting the application, submitting the job onto the Spark cluster. So we will see that particular stuff as well once all these three phases are over. So moving with the processing, phase 2, processing or transformation on top of our data, or let it be phase 2. Okay, so let me open the IDE, and are you able to say rename? Rename is over here. Let me copy this. Cancel, and let me create one another file. Okay, so let me copy this boilerplate code in order to create the Spark session. Okay, so what we have done over here, we have imported a Spark session, and then we have created the Spark session over here. That is nothing but the entry point to the Spark cluster. Okay, so look and feel. Look and feel, that is the title for this particular session. Okay, now what we are having, say we are having this particular file. Okay, we are having this particular file. I'm trying to read this particular file, that is of CSV format, and header is true over here. Infer schema, that is true. Mode is permissive, and this is the path of this particular file. Let me try to check the records of this particular file. So current file, I just need to have the execution of current file. And what has happened? Something that is rename. So extension was not correct. And let me do the execution. So the execution has been started and it is in progress. And just have a look. We are able to see uh, the file, and let me mention header is true. Okay, so it will give me a good picture of this particular data set. So what I'm talking about in this particular session, we will be going to take the look and feel of this particular data set. Then what I will do, I will try to have certain problems based upon the data, and then we will be moving in order to apply the transformation uh, to get the outcome on top of that particular data. Okay, so first of all, like we will be going through with certain uh, functions in order to get look and feel of this particular data set. Okay, so with respect to the look and feel, so this is the first operations dot show. Okay, data frame dot show. What this particular function is doing, it is going to provide me the top 20 records from the given data. Okay, say 2gbbs.csv, this is the file, and from this file I'm getting top 20 records. So dot show is going to provide me the information of top 20 records from the file. Okay, from the given file. So let me mention over here dot show, df dot show provide 20 records. 20 records from a given data frame. Okay, so reading data is the data frame in our case, and from this particular data frame we are trying to get top 20 records, and with the help of this, like we are able to see or get the look and feel of the data. Like say first column is serial number, second is having date, third is bsc name, fourth one is 2g site, and drop call rate, sdccs drop call rate. So we are able to get the look and feel of the data what is there in 2gbbh.csv file. That is fine. Now I have not defined the schema for this particular file. I have not defined the schema, and I have utilized the Spark functionality in order to infer the schema of my 2gbbs.csv file. So let's have a look with respect to the schema. Okay, so we are having a function dot print schema. Okay, so reading data dot print schema. Okay, so print schema, and it will try to provide me the schema for this particular data set. 2gbbs.csv. Okay, that is the file, and on top of this we have created a data frame reading data. Okay, so we will be getting the schema for this particular file. So with respect to each and every column, we will be getting the information. Print schema. Okay. Okay, so serial number is of integer type, date is of string type, okay, BSC is of string type, okay, 2G site is of string type, 2G cell is of string type, this is of double type, double type. Nullable true, that means we can have null values as well over here. If nullable false is there, the false values will not be treated over here. Okay, so that is fine. Now you are able to see date is of string type. Now if you are looking to perform the operations on date, say date 1 minus date 2, then you will not be able to perform over here. How I will I get this particular information? Because the data type is string over here, so we need to perform the typecasting and all. Okay, that we will see how to change the date formats. It might be possible, say you are performing the joining. Okay, you are having one data one file that is 2 GB bh. You are having, say you are looking to perform the joining with another file or another data frame that is having uh, say planning data. Okay, so you are looking to join those two files, or in another words you are trying to VLOOKUP, like you trying to get the information from another file to this file, or from another data frame to this data frame. So you are going to create the data frames on top of those particular files and all. So if this particular date is not correct, then you will not be able to perform transformation. So you need to like have, or say if you want to join and all. Okay, so or if you want to merge, then merging will create issue because you will be getting the different date format, and if you are going to perform the operations onto the different formats, then it will be tough, so you need to convert the data into a uniform format, we will see, like say if dd is there, if dd is there, how to convert into it into the uniform format, so how to treat different data types or different date formats and convert into the uniform one, we will see. Okay, so with the help of this print schema information, we are able to get that this is in a string format, and if I need to perform like certain computation onto the date, like date -1 or date 1 minus date 2. Okay, so that is not possible over here. It will throw errors, because string onto the string we can't have minus operations and all, okay, so that is the stuff, so print schema is providing me the information about schema, like data type of each and every column, so df dot print schema provide the information about each and every column, and this is the stuff, example. Okay, so over here we are getting the information about each and every column from the given data set, a df.print schema. Now if you want to check how many records are there in this particular file, in this particular data frame, how many records are there, so df.count is there, okay, df.count provide the information, provide the total number of records. Okay, so let me show you total number of records, so let me comment this in order to avoid the processing, and reading data dot count, okay, so reading data dot count up, I need to print this, so it will do the calculation, and I will get nothing at over here. I need to print this particular count, or I can assign this particular count to a variable, then I can print that particular variable as well. Okay, execution will happen and you will get nothing. Okay, so execution has been done and no output is there. So what I need to do, I need to print this, so print total number of records, total number of records in 2GBPH report is perfect. Okay, so it will print the total number of records in this particular file. df.count. Reading data.count is going to provide me total number of records in this particular data frame, from this particular data frame. Just have a look. Okay, so total number of records in 2GBH is 1934. We are having 1934 records in this particular file. Now that is perfectly fine. So this much of records are there in this particular file. Now moving further, say if you want to get the head information, head like top 5 records, okay, uh, top 10 records. So head operation is there, and with the help of this we will be able to get top 5. If you want to get the last 5, then tail 5 is there. Just have a look. So reading data dot head, and you just need to mention a number over here. Okay, say 5. So, and you need to print this as well. Print, and just
Ashok, by default, what will be the count? If we not mention 5, then how many records it will show?
by default I have not checked. You need to pass the number. Let me check it. This is by default. I think it will print nothing. If we just need to pass number, its signature is like it is expecting an number. Just have a look. In pandas, I think it is 5. I don't know like what is the total by default number over here. I think it's not. It will print nothing over here. We need to pass a number over here. Okay, so by default is, yes, we are getting certain records. One, date is this one.
I think
So only single
only
record.
one
One record
single
is
single
there.
record.
Single record
One
is
record.
there. By default, one is there. Okay. And the difference, what is the difference? Like we will be getting these particular records as a list. Okay. So we will be getting as a list, records as a list over here. Okay. Say if you are going to mention 2, so we will be getting 2 records. Just have a look. Okay. So we are getting 2 records, right?
One more thing, it
So
will also show the total number of records as well, no? In head also. Total number
total
of
number of,
records.
no,
1934. Yeah, it is showing, na? In two
this is with
BBH is
respect to this one.
193.
This is
Okay,
with
okay,
respect to this
okay,
execution.
okay,
This
okay,
is
okay,
with respect to first line. Let me comment this
oh,
as well.
okay,
Okay.
okay,
Now it will show it will list the top 2, top 5, top 10 records only. Okay.
okay.
Same thing is with respect to tail operations like df dot tail. Okay. And this is the signature. Just have a look over here. It is expecting the number, right? Self, if you are so let me try to, Okay, so it is expecting like the number. So what we have seen in head, it is also expecting the number. So say if 2, so it is going to provide me 2 uh, records from the bottom. Print and say 2 records from the bottom. Just have a look. Okay, so 1994, that is the you can say last record what I think, and 1995, 1995, this is the last record. So two last record with the help of tail, you can say functions, we are able to get. So head and tail, uh, this is like in order to take the look and feel of the data. Okay, so show, print schema, count, head and tail, these are the operation in order to take look and feel of the data set. What data we are having, and what are the different columns and all, how we are going to process the data type and all. Okay, this particular information is there with respect to these operations. We are having many more operations. Okay, let me try to copy it over here as well. So df.count, provide total number of records. Oh, that is mentioned already. Example, df.head and df.tail. Okay, so that is fine. Now, like what we are having, if we want to check the columns only, yeah. Okay, so the column names and all, sometimes like we need to define the schema and all. So over here, if we are typing print schema, so it is going to provide me the column names with data type. Let me show you. If we are printing schema, so it is going to provide me the information about columns and its data type. But what if I just want to have the column names only? I don't want the column data type. And why we need to have this particular function dot columns? Okay, so let me first show you reading data dot columns. Okay, reading data dot columns, and let me print this. Okay, okay, so just have a look. Serial number, date, BSc, 2G site, 2G cell name. Okay, SDCCS drop call rate, drop call rate. This is nothing but the column names what I'm having. Okay, now you need to tell me where I can utilize this particular feature. Df dot columns, where I can utilize this particular feature or function. Just try to correlate where I can utilize this particular function df.column. Tell me. And let me try to give you a hint. Okay. Say we are getting, we are going to perform the joining, say onto 2G site name, 2G cell name. So we are having two data frames that is having certain data, and over there 2G cell name is there. Based upon that, we are going to perform the joining. Now the joining condition, what I have mentioned, like say join on 2G cell name. Okay, 2G cell name. You can say df1 dot join df2 on 2G cell name, and join type is left. So I have written this particular statement. Like df1 is going to join with df2 on 2G cell name. Okay, so 2G cell name is there, that is the column name. That is the column name, and it must be available in both of these two data frames. df the df1 is there, df2 is there. If both of these two data frames are having 2G column name, then it is going to perform the join type left, and I will be getting the join data frame, right? But say if this particular column name, it might be possible, okay, the columns that you are getting in data frame 1, that is say 2G cell name. Okay, let me mention say in this way 2G cell name, and over here we are having 2G cell name. Will this particular join work?
Here we can put left on, right on.
But if this particular condition is mentioned, then and left alone and line right on, then that will be full outer join. No, that will not be left join.
No, we can mention this how equal to left or inner or anything we want to join, and left on means it will take from the df1 which column, and right on, if the column name is different in second data frame, then it will take the column name from the
But
df2.
will it
In pandas it works.
we can mention like df1 dot column this equal to df2 dot column this, right? We can mention in this way. But if I have mentioned in this way, will it work?
Single on it
Hmm.
will not work because both the columns are different, na? Column names.
Hmm. Column names are not same, so it will not work. So what we can do, we what we can do in both of these two data frames, I don't know, like say someone is going to type 2G, or someone is going to type say 2G, and someone is going to type say name in this particular format. But what this particular statement is going to do, it is going to you can say change the statement, and the column will not be existing in my joining condition, and the join will fail at that moment. So if I'm able to convert, if I'm able to get all the column information, and this is with respect to one column, it might be possible on drop call rate I have performed certain functions with another, you can say, table. if onto the date as well, like date is mentioned over here, somewhere it is mentioned date column, somewhere it is mentioned say data. Okay, so what I can do, I can convert these particular, you can say, column names into the smaller one lowercase letters, and the chances of the errors will be reduced, huh? Okay, so df dot columns dot lower, and then it is going to like take all the columns from this particular data frame, and it is going to convert those particular columns into the lowercase, huh? Okay, so that can be the usage. Second one, like if you want to define your own schema, uh, you are not happy what the Spark has defined, you first like try to infer it, and then you got the column names and all information, and based upon these particular column information you are having that this particular date must be of date type, huh? Currently the Spark is taking it as integer. If say you are having 200 columns, then it will be tough to find out 200 columns. So with the help of df dot columns, you will got all 200 columns, and you can define your own schema based upon that, huh? Right? So in this particular way we can utilize and df dot columns, right? Fine. Any confusion?
Yeah, fine, sure.
Okay. So df dot column, huh? So that is the stuff, and these particular things are utilized a lot, huh? Okay, like changing the column names to lowercase and all in actual production environment. These particular things are utilized. Now we just need to have the uniformity, huh? And uh, say date column, huh? So date, the column name is date, and say if you are going to perform the operations on date, then we need to, and we are taking the inputs dynamically from the user. Say certain data is there, which is generated from the UI. Okay, and based upon that particular data you are going to perform the operations onto this particular data frame, or these particular columns. So it might be possible like data frame is having something else, and your uh, sorry, metadata is having something else, or your data frame is having something else. Then you need to change the things so that it will be able to map with metadata, and you will be able to get the actual outcome. You need to play smartly, and you need to have a dynamic version of your code. I will guide you how those particular things will work. There will not be any issue, but at this moment what we are going to have, like the small functions which we need to use, which we need to learn, and those particular functions will be playing a critical role in our future coding journey, yeah? So df dot column is one of them, and this is utilized a lot, like changing the columns names to the lowercase. Second, like in order to define your own schema and all, so that can be utilized over there, df dot columns will provide you the information about all the columns, let me mention over here df dot columns as a list. So Pankaj, you were talking about this and join df2 2, and where like what it will be, df1 dot say this one, cell name equal to df2 dot cell name, right? You're talking about this, huh? Is it?
Yes, yes, Ashok.
Okay. So that is fine. It will work. But if we are mentioning in this particular way, I have. If we are mentioning in this particular way, to G, huh? Okay. So it will not work, huh? If the column names are not same, huh? Right? Okay. Perfectly fine, huh? Moving further, what we are having certain more operations. Okay. Say data type, if you just want to check the data type, so df dot data type is there, d types, df dot d types, so print and d types, okay. So it will provide the information about the data type, data types. Okay, it is d types, not small. It is small d, d types, not capital D. That is mentioning. Did you mean d types? Data frame object has no attribute d capital D types. Did you mean D types? Huh? So we just need to mention the small d, and try to go through with the errors. If you are getting certain errors while executing your code, just try to go through with the errors in detail. It will provide you a lot of information. So try to go through with those particular error logs, and like make a practice. So if you got error, try to find out what exactly has happened, what you have done, and why you got that particular error. Don't try to solve them, the issue. Try to check what is the error with respect to this, and try to document those particular things. It will be good for your learning journey. So again, we are getting the issue. D type, types, that is fine. Okay, okay. We need to remove this.
Parentheses should not be there, na?
Yes. We need to remove this. So if we have used, we have like typed in this particular way, reading data frame dot d types. So it will, we will be getting the information from the ID that no parenthesis will be there. You press enter, nothing will be there. Okay. If you are like typing print schema and all, and you are pressing enter, the parenthesis will come automatically. And this is the beauty of like ID. That is going to, you can say, take the stuff, the code, and provide you certain betterment. So from the ID, you get a lot of information. If you are typing it uh, onto, you can say, Jupyter ID, this much of information will not be there. So PyCharm is giving you a lot of information in order to get the insight from the code. If like certain libraries are not there, it will provide you the suggestions and all. So just have a look over here, reading data dot d types. So we are getting the information about the data type with respect to each and every column. Okay, BSC string, 2G site string. So this is a normal functions in order to get the information about the data type and all. Okay, so this is what we are having, d types. Now what we are having a function describe. Okay, describe. So df dot describe, df dot describe. Let me try to have the execution. Describe and dot show. Okay, just have a look now. Okay, so describe probably you have utilized in pandas as well, right, Pankaj?
Yes, yes, Ashok.
Okay, so almost same stuff is there over here inside the PySpark. So df.describe. So say count, we are having these particular columns in this particular data frame, reading data. So count is this one for each and every column. What is the mean, standard deviation, mean value, max value? Okay, so that is what we are getting with respect to df.describe. Okay, we will be able to get, like, if certain missing records are there. Say if this particular date is having 1904, so that means 30 records are missing. 1924, 10 records are missing. So we will be able to get a view of the data frame, like mean value, standard deviation, mean and max values. So we will be able to get the outlier related information as well. So say drop call rate, this is the highest drop call rate, 31.74. The drop call rate, SDC is drop call 31.74, and drop call rate, that is 20%. So we are able to get the information about the data frame, mean, max, standard deviation, count. So that is the stuff which is given by describe. Okay, it is going to describe your data frame with respect to, like, how many records are there, from a column perspective, the what is the mean value of a particular column, what is the standard deviation, mean value and max value. So that is given by df.describe, right? Then explain is there, df.explain, df.explain. Okay, so it will provide you the physical execution plan, uh, provide you the physical education plan, execution plan, execution plan, physical execution plan. So let me type it over here, reading data dot explain, and let me print it. Is it taking dot show? No, it will be coming with print only. Okay, so physical execution plan, that is very important in order to have the optimization of a particular job. Just have a look, and same thing is given by Spark UI as well. So physical execution plan is available in Spark UI and over here as well. So this is the physical plan. So say file scan CSV, that is having these particular columns. Okay, and the format is of CSV, location is of this one. Okay, then partition filter is this one, push filter is this, read schema, so it is going to read the schema and all. Okay, so this information is there. As we are not performing major operations over here, then this particular physical plan is, you can say, having this information only. Let me try to uncomment these particular operations. Okay, and the physical execution plan will be changed.
Ashok, what
Just
is
have a
this
look.
partition filter and push filter?
Okay, basically, inside the Spark, what is happening, like we are having certain optimization techniques, say AQE, that is adaptive query execution. So once we are performing the execution of our code, then what is happening, Spark is going to analyze our code, and with respect to the analysis of our code, Spark is performing the optimization and all. So partitioning filter, what is the meaning of this? Say if Spark is analyzing certain stuffs, certain partitions are there, or what I can say, some partitions are there which are of low size. So it is going to merge those particular partition into the bigger one. Okay, so that particular optimization is there, or if like we are performing certain operations and all, so it is trying to move the required data only, it is trying to shuffle the required data, because like data shuffling will be there among different, you can say, machines. So it is trying to minimize the shuffling. So in order to have that particular minimization of shuffling, it is trying to apply certain filtration so that the required data will be moving, unwanted data will not move down. So that particular stuff is nothing, that is given by these particular partition filter, post filter, predicate push down. So a lot of things are there, we will be learning during the optimization and all. Okay, so, and let me try to show. Just give me a minute. Hmm. Okay, so let me start the execution. Is this the correct one? Could not bind off. 4041 is the correct one. Okay, SQL data frames. Okay, so just have a look what we were able to see over there. This is available over here, a file scan, txt value, data filters, okay, partition filter, read schema, right? Push filter. Are you able to see?
Yes, yes, Ashok.
Okay, so over here as well, this particular you can say physical execution plan is there, and we will be able to get the information that like which part is taking, like metadata is taking say this much of time, number of files one, this one, size of the read, this one, so we will be able to get the information about like which step is taking too much time, and we need to focus on to that particular point, right? If a job stuck somewhere, then with the help of this particular UI or execution plan, we will be able to get the information, and we need to focus in order to optimize that particular stuff, right? So physical execution plan is playing a critical role while we are performing the optimization and all. Now we will see these particular things in detail, but at this moment, like we just willing to take a look and feel like how these particular how different functions are there in order to perform certain checks, and based upon those particular checks we will be proceeding for the optimization and all. Okay, so explain is going to provide you the physical execution plan of your data. Okay, so and same stuff we have seen over there on side the Spark UI, right? Moving further, what we are having a function that is sample, sample. So sample is there, sample. So like say you are having 1 TB file, 1 terabyte of data is there, and you are willing to perform certain operations on top of that particular data, and but it is tough, it is very tough or very time consuming. A lot of time will be consumed over there if you are moving with 1 terabyte of data. Okay, because like if you just perform simple operation in order to take the count, that will take too much time, so what you are going to do at that moment, you take the sample from that particular data frame, work on to the sample, and apply your logic over there. Once you are okay with the logic, that you are able to get the required outcome, then you proceed with the entire data set. So sampling is a good function. You just take some sample data from the given data frame, okay, and work on to that particular data. So how to take sample? Data frame. Okay, so we just need to mention df dot sample. Okay, df dot sample, and it is going to take 3 parameters with replacement. Okay, with replacement, and the value will be say true or false. Okay, then what we are having the fraction and seed. So these are the 3 parameters which are passed while taking the sample. So what is the meaning of these particular parameter with replacement? With replacement, then fraction and seed. Okay, so with replacement, it is true, either true or false. Okay, true or false. So once I'm going to take the sample, say if I'm having 10 records, if I'm having 10 records and say I'm going to take 40% of sample, so fraction is denoting say dot 04 04 sorry 0.4. The value will be between 0 to 1, 0 to 1. Okay, it is denoting like the percentage of records. So if I want to have 40% of the samples, so the value will be 0.4, so fraction will be 0.4. Now now with replacement, so it might be possible the records inside this particular data frame are repeated, like same row is repeated 2 or 3 times. So if with replacement true is given, we can have duplicate records. With replacement true, we can have duplicate records. If true, we can have duplicate records in sampled data. If false, no duplicate records will be there. Okay. So this is the meaning of with replacement. Fraction is clear, and seed. So seed is a random number. Random number you can say put say 43. Okay. So if you are putting this particular 43, so what we are getting from this particular data frame, say if we are having 1, 2, you need to pay attention over here, 3, 4, 5, 6, 7, 8, 9, and 10. So say we are having 10 records and seed is set to say 43, and say in first iteration we got these particular record 2, 3, 4, 5. These are the sampled one, and I got 40% of the record from this particular function, sample function. Now if you have changed the seed, say 23, so it is not like you will be getting the same records. It might be possible, definitely you will got 40% record, but at this moment you might got say 7, 8, 9, 10, because it is going to randomly pick the records from this particular data set. And if this particular number is fixed, then it is going to like pick the same records which have been picked previously. If it is changed, then randomly it can pick any records, but in outcome you will be getting the 40% records only. Okay, clear? Is it clear?
Yes, yes, Ashok.
Okay, so let me try to comment this and apply the sample function over here. So reading data dot sample, and with replacement set true, I can mention in this particular with replacement equal to true. Okay, or I can pass the parameters. There is no need to mention the argument name and all. Okay, so with replacement, then fraction, I can give say fractions at 20%, and then seed value, I can give any value to seed, say 43. Okay, and read sample reading data, and I can pass it to a data frame, say sampled data equal to this one, and sampled data dot count. Okay, and let me take the print of this particular sample data. Total number of records in sampled data. Okay, Perfect. Just have a look. So we are taking 20%. So almost 2000 records are there in this particular data frame, reading data. And if we are taking 20% records, so almost 400 records will be there. Okay. So just have a look. Okay. So 392 records are there. So we have taken the sample. If you just want to take a look and feel, so sample data dot show, so it will provide you top 20 records from this particular sampled data frame. Okay, so just have a look. Okay, so randomly it has picked so it has started from 21, 20, 21, 24 is there, 29 is there. So there is no logic like why after 21, 24 is there, because it is going to pick the records randomly. Okay, and this seed value is going to denote like if we are getting these particular records 20, 24, 21, 24. So in each iteration we will be getting 21, 24. So those particular records will come up. Just have a look. 21, 24. And let me try to change this particular random number to 23 or 230, whatever. Okay, so the sample will be changed. Although it is going to provide 392 records, but the samples will be changed. Records will be changed. Okay, so just have a look. 2, 15, 20, 30, yeah, right?
Um,
Are you able to
some
get?
total number of records also changed to 410, na?
So randomly it is going to pick. It is not like based upon almost 20% will be there. It is not like say it will be fixed with 392. No, almost
Means it
20% will
means
be
it
there.
depends only on the fraction, na?
Yes, 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 yes. So
Okay,
20%
okay.
will be there. It is, and it will not be like fixed. It will not be a fixed number. 20%, like say you get 400, 390, 410. Like you will be getting. Uh, you will not get fixed number. Okay, nearby 20% you will get. Right? Say if you are going to
Yes, 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 Ashok.
change it to 10, then almost 20% will be there, but the sample records what we got in the previous execution, it will be changed. And you need to tell me why we need to fix the sample. Why we need to fix the samples?
Because if we will go to do any kind of transmission on the whole data, it will take a lot of time.
No, 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 no. Sampling, that is with respect to sampling. I'm talking about seed. Why we need have we need to have a fixed number with respect to seed? 21, 24. So I have changed the seed to 43, so same records are given. Okay, let me answer. So what is happening, what we are trying, we used to say apply machine learning algorithm onto the sampled data, right? We used to apply machine learning algorithms onto the sampled data, and once we got the output, okay, and we used to vary certain parameters in order to improve the accuracy. Okay, in order to improve the algorithm accuracy, we are trying to tune, we need to try, we need to have the tuning of certain parameters. Certain parameters are there. Say if we are taking about the example of k and n, okay, k nearest neighbor, so n is the variable over there that is denoting, say I am going to consider this much of neighbors. Let me mention over here. So KNN is the algorithm which is working on n nearest neighbor. N nearest neighbors. So in order to improve the accuracy of the outcome, like say I have applied the KNN algorithm, so I'm trying to tune the value of n equal to 3. So it is going to consider 3 nearest neighbors in order to have the calculation. If I'm tuning it to 4, then it is going to take 4 nearest neighbor. Let me show you the diagram as well. Okay, so we used to identify a point, okay, and from that particular point, we are trying to calculate the category. Is it belonging to category A or category B? So from the distance, uh, like from this particular point, the distance is being calculated based upon the n values. Say I'm going to consider 3 or 2 or 5. So based upon that, like categories are being calculated, determined. Say it is the red ball or blue ball. So based upon the nearest neighbor information, we are going to calculate the accuracy. Okay, and it will vary, the accuracy will vary based upon the n value. Okay, so if we are going to fine tune, if we are going to tune the accuracy or improve the accuracy of this particular algorithm, and we are trying to make it by tuning the n variable, we are having multiple variables. Okay, we are having multiple variables which are tuned in order to improve the algorithm accuracy, but we are tuning parameters over here, and the input, the seed is not defined. So say 10,000 records were given, 10,000 records were given, and I have tuned the accuracy. Now I will not be able to get it, is it because of data or because of the n variable? Okay, so what I need to do, I need to pass the the records which was passed previously. I need to pick up those records only which have been passed in previous iteration, when the value of n is 2 was 2. Now the value of n is changed to 3. So I just want to pass those particular I just want to iterate the algorithm from those particular values only. Yeah. Are you able to get, all of you?
Yes, yes, Ashok.
I want the input from each one of you. Rohit, is it clear?
No, no,
Naresh?
no. It's can you please repeat this part? Is
Okay,
not clear.
okay. So what we are having machine learning algorithms, and different machine learning algorithms are there which are applied in order to predict something. You can think. Okay. So we are having one algorithm, k nearest neighbor. Over here, n is the variable which we can tune. Okay. Say we have changed, we are taking n as equal to 1, and we are passing our data from this particular KNN algorithm and getting the output. Okay. So sample data was there. Sample data is passed from this particular algorithm and got the accuracy, say accuracy point, say 90, say 90% accuracy is there. Now n equal to 2 is tuned, but the input records have been changed. So I will not be able to analyze, I will not be able to conclude that this particular change is change in accuracy is due to this variable change or the seed value change, right?
Yes, yes, right, right.
Okay, so we need to fix the records, because like once the seed value is changing, then the records are near to 20% only, but the records information, say if it is taking 2 3 4 5, then it is going to take 7 8 9 10. Okay, it might be possible 6 7 8 9 10 in order to provide the the records with respect to a seed value. But the seed, if we are taking seed, if we are going to fix the seed, we will be getting all these particular records, say 21 24 29. In each and every iteration we will be getting 392 records only. That is, you can say 20%, almost 20% of the reading data frame. Okay, if you are going to change the seed, say point seed is changed to 0.5, okay, seed is changed to 5, so what it will do, it will provide me almost 20% of the records, but the records will be changed. It will not be started with 21. Just have a look.
Ashok, if we keep seed as 43, but we change fraction from point to point 3, then also the
Then
records will remain same like 21, 24.
no. It will add 30% record, 10% records more.
But it will start like from 21, 24. That will remain there, na?
21 24 will be there, but it can add more records, say 1
Add
2
more
3.
records.
Okay.
Okay.
Okay, so this is nothing but seed. I think that is fine for today's session. Tomorrow we will have more, you can say, a discussion onto the transformation side. From the look and feel perspective, these are the operations what I just want to show. Okay, in tomorrow's session, we will be having a discussion on to like how to refer a particular column. Say we are having different columns in a data frame, how to apply filtration, how to apply group by, order by. Those particular things will be covered in our tomorrow's session. Okay, that's it.
Fine,
Okay.
Ashok, fine.
Thanks.
Fine.
Thanks, Ashok. Yeah.
Okay, okay. Take care. Let me stop recording.